Good afternoon. I, Professor Radhika Malpani, welcome you all to the day 2 of FDP on prompt engineering and agentic AI for next generation teaching and research, organized by the Department of Computer Engineering of Shalaka Foundation's Keystone School of Engineering. Before starting with today's session, let us take a quick review of yesterday's session. Day 1 session was conducted by Mr. Aditya Thakare on foundations of generative AI and prompt engineering. Today's session will be conducted by Mr. Rajesh Pandre sir on advanced prompt engineering techniques. Mr. Rajesh Pandre sir is an experienced AI technology leader with over 18 years in software engineering, specializing in generative AI, retrieval augmented generation (RAG), and multi-agent systems. He is currently a tech lead AI/ML at Kanaka Software, where he drives AI strategy, builds high-performing teams, and delivers production-grade AI solutions. His work includes designing RAG pipelines, orchestrating LLM agents, and deploying vector search for real-time insights. Sir is also skilled in mentoring engineers and aligning technology roadmaps with business objectives. I welcome Sir on behalf of Keystone School of Engineering. I request Mr. Rajesh Pandre sir to please start the session.
Hi. Good afternoon, all, and welcome to the FDP. And today's we are learning the advanced prompt engineering techniques, which are used to prompt LLMs. And the LLMs which we are talking about are the prompt engineering scenario was very different. But nowadays, with the advancement in LLMs, the reasoning capacity of LLM also increased. And the latest LLMs like GPT from OpenAI, it's GPT 5.5, then Cloud Opus 4.7, and the other latest LLMs like Gemini 3.1 Pro. So these models are best in doing the internal reasoning, and because of that, some ways of prompting them is now changed. So we will focus on that part for today. So to start with, we'll start with the basic difference between the LLM and the Google search. So if we, I have shared my whole screen, so you can see, I think, whole screen and what I am doing right now. So if we go to the Google search and say we are giving the just one line, just one word for the Google search, that is AI. So what Google will give is the index-based search available on its, indexing technique. So Google is a search engine, and it will provide the results based on whatever the search index it has regarding that word. But if we give the same word to ChatGPT, then we will see what is the response. So ChatGPT is not a Google search engine. ChatGPT is a predictive engine. So what the difference between the search engine and the AI LLM, or the way they both give output is, Google will give the output based on its search index, whereas ChatGPT or any other modern LLM or any other LLM will give the output depending on the prediction of the word. So when we say AI, the LLM will predict the next sequence of words depending on these words, and it will provide the output. So we'll see the basic difference between the output given by the Google and output given by the LLM is always different. And LLM always includes some percent of the hallucination, whereas the Google output is always an accurate output. So if we ask something about an Google, and if Google search index or Google don't know anything about whatever we ask, Google will not give any search result. But if we ask very vague response to the say LLM regarding like what is the population of say Wagholi village in 2026. So this don't have any correct answer, but still LLM will produce something for us, and LLM will give the output as per the its prediction. So this is the difference which we need to understand between the Google and the LLM. So LLM will predict something for us, and that prediction will always be there. So if LLM don't know anything, it will not say no to us. It will give some answer to us. So here, what LLM has given is it has a census record of 2011, and as per that it has added 2% per year increase, and it has given 2026 answer as a 48,000. But if we really like, if you actually see the today's population of Wagoli village, it is like very like difference is very vast. So that's why we need to understand that the LLM will always do some hallucination, and that hallucination we need to understand. So main say basic rule when we give some work to an LLM, the basic rule is that work first we need to understand, and we need to know the outcome of what we have given to the LLM. So if you don't know the work which you have given to the LLM, then if LLM hallucinates, then it will always be a bad response. Or if you are submitting some research paper, and that research paper you totally depending on the LLM output, and if you submit that research paper, then that is full of hallucination, and it will get rejected in the first filter. So this way we need to understand that LLM always hallucinate, but there is a way to reduce the hallucinations which LLM will produce, and that is the advanced prompting or the prompting techniques. And today's session, we will learn different prompting techniques which will reduce the LLM hallucinations, and which will force LLM to give us the proper and accurate response. So from that manner, we will see the first, advanced prompting technique, and that is the so before going to the prompting technique, we need to understand what is token, what is the prompt completion, what is the parameters, and what is the hallucination. So hallucination we have seen. So hallucination is an confident of LLM to giving the wrong answers. So prompt is the instruction which we give to the LLM to get the answer from the LLM. And then tokens are the subwords. So tokens are generally say 7,000 words equal to 1,000 tokens. So that is the vague uh, parameters which we use to calculate the tokens. And regarding the prompt engineering, we have old way of prompt engineering, that is 2023, and the new way of prompt engineering, which is the 2026. So the difference is, we in old way we always give LLM something like an act as an engineer, or act as a teacher, or act as a professor and give me this answer. But in a new way, we are focusing on the output, not the focusing on the initial part. But here on the new way of 2026, we are always focusing on the output oriented prompt, or the goal, or what is the success criteria which we always give inside the prompt in advance, so that LLM will know this is the good answer and this is the bad answer before it will give the answer to us. And the old way of the prompting is always think step by step. So here what the think step by step will do is like, it will ask LLM to think before giving us to the answer. And this think step by step is only useful for the models which don't do reasoning. So the GPT-4o, the old models which were not non-reasoning models, that models will only use the this technique. But if we use this technique to the modern LLMs like GPT-5 or the Opus 4.6 or 4.7, then this will only increase the tokens, means it will only burn the tokens, but it will not improve the output given by the LLM by any means. So this is like the we are just wasting our tokens by doing this thing step by step in the modern LLM way. Then a long predictive instruction. So before it was style of giving LLM all the context and all the informations which is unnecessary. But now, if we give the very long prompt to LLM, the modern LLMs will get confused. So we need to follow this CTCO framework, which will we will see in some time. What is this CTCO framework? And if we provide our prompt in exactly the CTCO framework way to the modern LLMs, we will always get the proper, accurate, and what is required output for our input. And in old way, we also used to give the one giant prompt. So like if I need to write a thesis or an essay, I will provide all the information in one prompt in old way and will ask an output from an LLM. But in a new way, what we need to do is we need to break down the prompt into the smaller chunks, and we will provide the step by step, the input, and then we will improve over the output given by the LLM. So the basic, the basic and the common technique for the modern LLM is the react. So means what do you mean by react is reason and the act. So what is reason and act is say like I have done some work, okay, as a human. I have prepared some say essay, and I need to submit it to the some competition. So what I will do, if I have written the essay, I will then do in the next pass is think or read this essay as a whole and think from the competition point of view that if this essay is okay or it will require some improvement. So that means I am reasoning over my output, and I will improve my output depending on the reasoning outcome. So if I think that this essay is short in terms of the say elaboration of some point, then I will give a second pass. I will rewrite that essay in such a way that the drawbacks or the negative points will get overcome, and then I will prepare the next version, and then again I will reason over it, and once I will think that this essay is perfect for the competition, I will submit it. So here what I have done is I have reflected over my output. And as a human, we always do reflect over the output which we have created, and we will always improve the output depending on that reasoning. But in an LLM, that needs to be triggered externally. So how we will trigger this externally is like, say, for this if I have given the like write an essay on India youth uh, in 2026 in 500 words. So here it has given me the first pass, the Indian youth in 2026, 500 words. It has written the essay. It has given me the first pass. But now, as I need to reflect over this, means I need to trigger the reflection of an LLM over this. Then what my next prompt will be? My next prompt will be is like, okay, so once this output is finishes, I will give next prompt is like, okay, reflect over your output two times back to back and implement all the feedback from the reflection rounds and then only provide me final output. So we'll see like what magic it brings to the output. So here I have forcefully asked LLM to reflect two times over its output, means think if that output is a perfect, and if that output is not perfect, then I have also asked him to the implement all the feedback from the reflection round and then only provide me the final output. So it will do the reflection of two rounds and it will find out like what are the negative points in his essay. Then it will again rewrite it in such a way that all the points, negative points, will get overcome, and this is the final polished output it has provided. So if we see the first output and this output, it has like major difference in terms of writing and in terms of the say the quality of essay. So this is like, okay, this is like the final polished output which LLM itself has done reflection two times and given me the final polished output. So this way we forced LLM to reflect on its output and give us the proper well thought output in terms of the implementation of the all the feedback. So this we have forcefully asked LLM to do the correction round two times and then give us the output. So this way this modern 2026 prompting techniques always say take advantage of the capacity of LLMs, which we now increased capacity of LLMs which 2026 models can do. So now 2026 models, every model can do the reasoning, and that reasoning means thinking. So what is the reasoning in terms of LLM is like when human do the reasoning, that means human do the thinking internally regarding if my step like or whatever I am doing is a correct or not. But in terms of the LLM, reasoning is like an mimicking that behavior. So LLM reasoning is equal to acting like an human to think. So it is an mimicking humans behavior of thinking, but in that way it will always mimicking all the things which we do internally for reasoning. So that way it always go through its input and it will always find the negative points from this input and it will list it down, and if we say implement a feedback, then it will do the feedback implementation round and then only it will give us the output. So this way for submitting some thesis or for submitting some writing work and for submitting something which is creative, this reflection rule is very useful and it will always produce the quality output. So here we will see the main this CTCO technique, and CTCO technique means C means context, and what is the context mean? The context is regarding the who is the model, who is the user, and what's the background. So whatever the history or whatever the information which is regarding that task which we are giving to an LLM is known as a context. So for an solving the maths problem of the first year of engineering, I will provide an LLM information regarding this is a maths problem from the first year of engineering, and you need to you need to solve it like a professor so that it will be useful it will be very easy to understand to the students which don't have any background regarding this problem. So this way I am providing the full context of my problem to an LLM. Then task. CT task is like a specific things which we need LLM to do. So it is a task is like, okay, right, sort or whatever the task exactly which we want to perform the LLM, that is comes under this task category. Then constraint is a regarding the output, what tone we want, or what length of output we want, or what exactly we don't want in our output. All these constraints or the all the parameters regarding output which we will provide under the constraint, and the output is an exact format, a table JSON or forced fenced code or bullet count. So here we need to understand one thing is like I am asking something to the chat GPT. Okay. So this is the text output chat GPT is giving. But in case of multi-agentic scenario where one agent will pass its output to the next agent, in that case, agent don't need this text output. Okay. So when agents are talking to each other, so if we are building something and multi-agentic, say one agent is like a writing an essay agent, okay, but the next agent is a reviewer agent who will review on some parameters regarding the quality of the essay written by the writing agent. Then the review agent don't need this plain text output, because for the LLMs or the machines, the best understandable output is an markdown or an XML. So uh, uh, um, in that case, what we need to provide is an for an agentic pipeline is the agent which will pass its output to the next agent. That agent must pass the output in a, say JSON or the XML or the markdown way. So that means the exact output format which we will ask an LLM to produce when it will create an output. So once in case of multi-agentic pipeline, the output should not be always a plain text. It should be passed as an XML or an JSON or an machine readable format like a markdown XML or JSON. So this way, the next agent which will process that output as an input. So next agent, like say, essay writing agent has created an essay, but now the reviewer agent needs to process that output as an input. Then that agent will process that output easily if that output is in machine readable format. So XML, okay, JSON okay, or Markdown okay, because these formats are well understood by machines. And AI agents are generally like, they are in way machines only. So one agent if passes output to the next agent, it should be always between the JSON, XML or the Markdown. So this way output format also we need to ask an LLM to give output as only in these three formats if the we are building the agentic pipeline. So we will see one example here. Okay, so here the main example is in case if we need an in case if we need an output of an LLM in these three formats, then we need to specify the XML tags, like these are the XML tags. Output format is equal to JSON. So in this output format type, we need to provide the output format way which LLM needs to be returned. And if we say this prompt, I will run using the chat GPT. So we'll understand this from like you. So system is like you are a friendly engineering tutor for SPPU second year IT students, and summarize the key topics of discrete mathematics SPPU SC syllabus as a markdown table with the three columns. Okay, so here output format we have given as a markdown table with three columns. So output format also we have given the like strict three column format, like topic, one line definition, common, and this common, and then exam question is like cover sets relationship. Okay, so I will run this prompt now. So if we see here, the output given is exactly what we want. So topic, one line definition, and common exam question. So set a collection of well-defined object and solve example of union intersection different. So this way we have asked LLM in advance, like what exactly output format we want. And we have also given that output format instruction in our prompt. So here, if we see, here we have given like a markdown table with three columns, topic, one line definition, and a common exam question depending on the topic. So LLM has exactly given this topic, one line definition, and common exam question depending on this topic in the SPPU exam. So this way we have asked LLM to exactly what output we want, and LLM has exactly produced that output. So this way it is, we have forced LLM as per our CTCO framework to give us the exact output what we want. So this way, this format is very useful in case if you want to get some specified output from LLM, and in multi-agentic way, this is always best to provide an LLM the exact output format so that next agent will easily churn that output. And also in a multi-agentic way, there is also one more thing which we need to understand is like, say we have, so we are, for a university exam, we are creating a question set depending on the all past university question papers. So in that way, we need to scrap the sites which have the question papers, and we need to collect all the questions. But for the scrapping, we have deployed, say, two or three agents which will scrap various sites which have the past university papers, and then it will create a question set. But now what happens is, say one site has an one format, another site has an another format. So this way, it is always, now our pipeline is like three scrapper agents which will scrap the various university websites, and then one synthesis agent which will collect output of all these scrapping agents and which will create a final question bank. But now what is the problem with synthesis agent is, synthesis agent has to churn output from three different agents, and three different agents are scrapping three different websites, and that three different websites have their own structure. So will it be possible for a synthesis agent to accept an output in one format from one agent and then process, then accept an output from another format in from the another agent? So it is like we are, say passing very unstable output to the synthesis agent, because LLM, because the prediction in LLM is always very less. So it is, if we ask one question two times to the chat GPT, both times we will get the different answer. So that means every time that agent which do the scrapping will always give something a different format, and it will pass it to the synthesis agent. And then the programmer who wants, who is coding that synthesis agent, how he will code, or how he will, write a parsing logic where the scrapping agent's output will get parsed and will then converted into the question bank. So it is very difficult for that person to code if the input always gets changing. So that's why in that case also this output parameter will always be useful, because in a Python there is one concept of pydantic, validation. So if all these scrappers will send the output in a fixed pydantic form. Pydantic form means a very strict form, like okay, this is the output which has, first thing is number of years of question papers, and then exactly the question papers which have scrapped. So if this form is fixed, so one XML column contains the year of the question paper, and another XML column contains directly the questions. Then it is a responsibility of that scrapping agent to convert his scrapped output into this pydantic form and send to the next agent, that is a synthesis agent. So in that way, what we have achieved is like, now the programmer or coder who is coding for that synthesis agent has always a fixed format of the input from the scrapper agent. So this way it will always now know like what is the question paper here and where are the question. So this way it is very easy for him to parse the input and then convert it into the question bank and then arrange it sequentially. So this way this output structure is always better for the multi-agentic pipeline, where the previous agent will always send his output irrespective of the input or irrespective of the scrapping thing. It will always send his output to the proper bounded way, and then with this bounded way the next agent will always churn its input in a proper format, so that it will not get confused every time by seeing the new way of input. So this way, this output parameter is very useful for the multi-agentic pipeline, and it's always, mandatory for nowadays multi-agentic pipeline to follow the strict input-output format for every agent, so that next agent will not get confused by seeing new output or new input every time. So this way, it is very useful for a modern agentic pipelines. So now the next technique is the few shot learning. What is the few shot learning technique is, it is mainly we are showing LLM the way what is the correct output is in 2 3 examples. So here if we see the elaborative example here. So in few shot prompting is like giving 1 5 work example inside the prompt, and zero shot means no example at all. So generally when we query to the chat GPT, we follow this zero shot technique. So we don't give any background or we don't give any learning example to the chat GPT. We are totally depending on its internal knowledge, and we will ask directly questions to chat GPT. So generally we follow this zero shot technique. But in case there are some classification ways or the some classification examples where say one say we have a Keystone Google review site, and many people do go there and review about the Keystone, and now we need to write one AI agent which will go to the review outputs and it will collect the sentiments of the students regarding the Keystone College of Engineering, and then at the end of the day, it will create me a report and it will give me what are the good sentiments, what are the bad sentiments, and what are the neutral sentiments, and what are the overcoming. Like today, is it good or it is bad reviewed regarding the Keystone? But for that thing, as an LLM, every statement is the same, but we need to teach LLM like what is the good review and what is the bad review, and that we can do using the this few shot prompting technique. And how we can do this few shot prompting technique is this example. If you see here, so classify the customer feedback as positive, neutral, and negative. This is the task for LLM. So if we give, this is a task for LLM, classify a customer feedback as a positive, neutral, and negative, and then we will provide the 3 to 4 examples regarding what is the positive feedback, what is the neutral feedback, and what is the negative feedback. So next is an example. So example we will provide: the new mess food at COEP College of Engineering is amazing. So this is then one statement, but for an LLM this is just a token statement, but for a human this is a good sentiment or bad sentiment which we will provide in terms of the label next. So the new mess food at COEP is amazing. So it is an amazing, that means it is positive. Then Wi-Fi sometime works, sometime doesn't. So this is a like, we don't need to provide the correct like exact statements which are regarding the review, but we are providing a general example, general English natural language examples like how human talks about the good sentiments or the bad sentiments. So here the Wi-Fi sometimes works, sometimes doesn't. It is a neutral statement. So we are not satisfied also, and we are not dissatisfied also. So it is a neutral statement. And then library closes too early, that is ridiculous. So this is a bad sentiment. So we are categorizing it as a negative statement. So then once this example is done, then we will provide and our input, user input, and ask him to classify. So this way we provide an LLM the 2 3 examples regarding how the good sentiments and bad sentiments will be, and then we will ask an LLM to provide. Then we will provide an actual problem statement, and then we'll ask LLM to now provide regarding is it a good sentiment or it is a bad sentiment. So we will see this by running it. So this it has categorized it as positive. So because I have given the say I have given this examples which help LLM to learn what is the positive and negative. I will again give like okay. So the say library administration is not very good and biased. So this we will see like if how much this categorized. So it is a negative. So using this example, it has categorized it as a negative. So this way, now whatever the now I have trained this LLM to categorize these statements depending on the sentiment. So now if I provide like multiple examples, it will categorize it as positive and negative. So this way now this agent is trained for categorizing the user feedback reviews into the positive and negative. So if I have say 1,000 reviews on my site, so I have some site which caters for the customer business or say catering business. Okay, so and that has 1,000 reviews, and I don't have time to gauge the sentiments of people. If my business is doing good or business is doing bad, then I will simply create this type of agent programmatically, and then I will provide all these 1,000 or say 1 lakh reviews. So whatever reviews I have for 1 year reviews, accumulated reviews, I will provide this review file directly to this agent, and then this agent will categorize each review as a positive, negative, neutral, and then at the end of that review cycle, it will categorize. Okay, you have 63,000 positive reviews, 47,000 negative reviews, etc. So that means my business has like maximum positive reviews, so I am doing good. So this way I can classify or I can use AI agent for the customer review classification. So this is the best example of classification agent which we can train and we can use programmatically to because some sites has says thousands of reviews and it is impossible for human eyes to gauge a general sentiment. For that way, this agentic classification is very useful. And how can we train this agent? Using this technique is like a simple giving few shot learning, or they this few shot prompting before advance to train the agent, so that agent will generalize its understanding and it will categorize each and every review in good, bad, or neutral. So this way, this technique is very important for the classification agents. And this is like few shots is the cheapest accuracy boost for the chat model, but skip for reasoning model. So because once if we see the Gemini, say Google's general agent. So if we see Gemini, we have say here thinking model, we have 3.1 flashlight, 3.5 flash, and 3.1 Pro. So in that case, 3.1 flashlight is a non-reasoning model. So, and generally, if we want to programmatically do the agentic work, then say Gemini models, Vertex AI. So when we generally do programming thing for an LLM, we don't use this chat GPT or we don't use the Gemini also. What we use is actual API to coding, like, to do the coding of an agentic application. And that actual API comes from the platforms like an Vertex AI from the Google, or the say OpenAI from the OpenAI from the OpenAI development platform, and or the Anthropic development platform. So this is the Anthropic development console where we can use the cloud models or the say different models from that particular provider. So here, if we go to the say build workbench, here we can select this number of models are there. So these are the different models from the cloud, which are available as an API. And from Google, we have this 3.5 flash, 3.1 Pro, and 3.1 Pro has an also the different variation. And also, if we see, every model has a cost associated with it. So if we see the pricing, here, if we see Gemini 3.1 Pro model, the 1 million input token, because an LLM, the input token price and the output price always different. So for a Gemini model, for input text input, always this is very expensive model because it is a Gemini 3.1 Pro, and which is the advanced LLM, which has $12 input cost and the $18 output cost. So whatever the say in ChatGPT, I am giving some command to ChatGPT. So I am giving like give me 200 lines essay on Keystone College of Engineering. Okay, so these are the input tokens which I am giving to the LLM. Okay, so these are counted as an input token, which are always cheap, but whatever these tokens now it is producing, these are called the output tokens. So in LLM world, the input tokens has a different cost and output tokens has a different cost, and majority wise output tokens has a more cost than an input tokens. So the cheapest models which we can use for an agentic work is not this perfect Gemini 3.1 Pro or preview models, but the lesser models like Gemini 3.5 Flash, which has this reduced input and output cost, or the Gemini Flash Preview, because this is very good model for the text input, $3 input and $3 output. And then the flashlight is very cheap, like 1.65 input and 1.65 output for the text response. So when we use this model generally are the non-reasoning models. And for the non-reasoning models, if we use into the multi-agentic pipeline, then what we need to do is we need to tune the output for the using our prompting techniques. So for the reasoning model, we don't need any hi-fi prompting techniques, but in a professional or say in an enterprise application way, where we need to produce a vast amount of data. So I have given example regarding the review site. So I have a business of catering, and I need to now gauge the user sentiments for the last 1 year. So now for last 1 year, whatever reviews there on my Google site, that needs to be processed using this LLM. So this means I need to process a vast amount of information. And if I will process this vast amount of information using this hi-fi model, Gemini 3.1 Pro, then I will be bankrupt. So it is like $12 input and $18 output. That means it is like, it will easily, say, eat all my bank balance in this token input and output cost. So for this type of work, which is not very, not very, say, intensive, or not very, say, conclusive work, because this sentiment analysis or the review analysis work is not like, if I have not done this, it will stop my business. It is not like that. So it is good to know that what are the sentiments regarding my business from the people. So it is not very important work, but it is good to know work. So for this type of work where the vast amount of data needs to be processed, I will always use this Gemini 3.5 Flash or the poor models, which are non-reasoning. But what I will do is I will prompt them in a such a way that they will produce a quality output. So this is the trick for the agentic application, and for the success, like, for making them successful enterprise wise. Because when you face the customer, in a real time customer, the customer will always ask, okay, you are producing something agentic for me. So you are taking some contract from some customer for doing an agentic work. But okay, main thing is the token cost which customer will require to pay every month. That is the main criteria for getting successfully launching that agentic the agentic program production, in production. Because if you have used this expensive LLMs for coding, then that customer will always needs to pay per month vast amount of money as a Google's bill for the token burning. But if we use this cheaper models like 3.1 flashlight or something like that, then for processing 1,000 or 1,000 or 10,000 pages also, it will be maximum, it will create a bill of $10 or say $50, and that is very, okay for a customer to pay every month. So this way it creates a vast amount of difference, by using the lower model, in terms of the every month token burning bill. So this is very important point to note. If you are coding something for a customer, always take into account his budget. Because this, if you are using AI for any work in his workflow, then that AI always needs to be paid by the customer in terms of monthly billing to the API cost. And that cost always needs to be in a controlled format, because if that cost will be skyrocketing, then the agent will or the customer will stop that project, and it will say, I will be better without this service, because the bill of every month paying the token amount is very high. So that way, it always needs to be think from that point of view. Okay, and then next technique. So we have seen this technique is regarding the two-shot prompting, where we always show 2 3 ways of good and bad output to the LLM, and then we will ask our main question. The next prompting technique is chain of thought prompting, or the step-by-step reasoning, or the self-consistency. So this we have already discussed regarding the reflection point of view. So this is like we will ask LLM to reflect on his input, so that reflect on his output, so that it will improve its output into the next pass. So but here one more point which we need to aware of is this chain of thought prompting will not be useful in terms if it is a reasoning model. So for the model like this, these are the advanced models. So Gemini 3.1 Pro and other reasoning models. these models always think themselves very good. So if your LLM is a very advanced LLM, then this chain of thought or asking him to reflect on his answer will not always be useful. It will just burn the tokens and it will increase the bill of tokens, but it will not improve the output in terms of the that spent money. So that's why if your LLM is a modern LLM, don't ask him to reflect or think twice or think thrice. But if your LLM is an old LLM or the LLM of like low category or non-reasoning LLM, then only this chain of thought or step-by-step reasoning will be useful. So the general prompt of chain of thought is like, say you have asked LLM to write an essay, then you can ask LLM to reflect on your answer 2 times and then implement all the feedback and then give you the output. So that is the chain of thought or the reflection prompt, which we have seen when we had the initial prompting technique. So main thing is on reasoning models, this chain of thought will not work because it will only marginally benefit despite of substantial time cost. So it will, if your model is reasoning model, then don't use this chain of thought technique. You can trust the output given by the modern LLMs because they always think and then only they will produce the output. But if your model is old or the less, say, flash model or the other model which are like not reasoning model, then you can always improve your output using the chain of thought. So generally, like solve this problem, show reasoning inside thinking tag, and final answer inside answer tag. So this way also you can see the thinking of the LLM. So if I give this prompt to the chat GPT. So here what I asked ChatGPT is show me your reasoning inside the thinking tag. So this will show me the what he exactly thinks while solving this problem using this thinking tags. So I have okay. So let's see like how he thinks. So you see here, this is the modern LLM, and it has taken like so much time of doing this because this technique doesn't suits well with the modern LLM. So here, as per our prompt, it has given its internal thinking. So this is its thinking block which it has given, and then it has given the answer. So what you think is like given principle. Okay, so this thinking generally it doesn't show, but if you explicitly ask in your prompt that show me your thinking inside the thinking tag, then LLM will always show this thinking inside this thinking tags. So these are the thinking tags. So thinking tag closing, thinking tag its tag is starting, and this all is only given to you because you asked explicitly. So this is the internal thinking block of the LLM, which it's shown because we asked explicitly in our instruction that show me your thinking. Okay, so this way you can force LLM to know what it's thinking internally, so that you can tune it in in more or you can mold its thinking into the different way. So this is very useful if you want to see the internal thinking blocks of an LLM. Okay, now so we have seen that LLM has a parameter of a temperature, and this temperature parameter is always like say yes. So modern LLM has some temperature parameter, and what the temperature parameter means is temperature parameter has value of say zero point 0.1 to 1. So and say 0.1 to 1 value means if we given value 1, so value 1 in a temperature, that means you are giving all type of freedom to LLM to think creatively. And when you give freedom to LLM, there is always a percent of hallucination will happen in your output prompt. So if temperature is 1, that means it is an open invite for LLM to do the hallucination or be more creative. So it is like an giving an say full say permission to an artist to draw the picture in terms of its imagination. So LLM can imagine here, and LLM will even LLM imagine it, then it will always produce an hallucination, or means hallucination means the answer may be accurate or may not be accurate. So this parameter always used with caution for a temperature. So in case if you want to do some creative work or some essay writing or to do some story writing, etc., this type of work you need to do it from an LLM, then always set a temperature of an LLM to close to the 1. And for the modern LLM, you can set temperature in, like, say, if I show you the Google AI Studio. So here is the Google AI Studio where we, set the temperature and everything for an LLMs. So I say Gemini. So Gemini Pro latest 3.1 Pro. Here, if we see in Google AI Studio, we have these parameters. At the right hand side, we have this run setting, and here the system instruction and then temperature. So I can set temperature to zero point 0.1 also, and I can set temperature to say 1 also. So this way you can verify, like vary the temperature. Then thinking level also you can set, like thinking you want low, medium, high. So this way, the structured output, if you want a structured output, then what is the structure of an output, etc. So this way you can set various, LLM parameters in Google Studio, and then you can ask query regarding this LLM, and then it will produce the output. So this is the way, and this AI Studio Google.com is a free for, say, like, say, 1.5 year from Geo, because this is a part of the Gemini product pack. So if you say this Gemini, because from the Geo free pack, if you are using only this free Gemini, then this Gemini always has this Google AI Studio also free. And in this Google AI Studio, you can do various things, like say for like I can show you one best example is images. I say Google Nano Banana Pro. Okay, Nano Banana Flash, or I will say Nano Banana Pro image, and then I give my okay. So I will give my one image to this. Okay, so this is the image I have given, and I want, okay. Now I want my dress to be changed to the say a white shirt. Okay, change shirt to white shirt and blazer. Okay, so here Nano Banana Pro, you can use it in various way, and because this Google AI Studio is very good in terms you want to do the work like an actual giving an actual prompt to an LLM, or fine tune your prompt to a multi-agentic project. So here I am directly giving to the Nano Banana Pro model, and now it has changed my shirt to white, and also given me the blazer. So this way you can see like which model you can use for your purpose, and then you can directly say play with the image also in this Google AI Studio. So the best prompt youngsters are using right now is like for the Instagram, they need to post some image. Then what they will give the prompt is like correct the beauty angle of the image or of the person. So beauty angle is like, for an Insta posting or for the Facebook posting, this beauty angle is very necessary for an youngster. And okay, so it is, okay. So now, now it is not giving anything. Maybe some problem with the Google. This happens, but I can always modify this prompt. Okay, correct. That's it. Okay, so it has, corrected the beauty angle of my face, and it has given it back to me. So this way, this picture is now ready to, post to the Instagram or Facebook. So this way you can, try multiple models, because in here Nano Banana has two variants. Like say one is the this variant has a $0.50 input and $0.3 output, but this variant has a $2 input and $12 output. So if I use this model of Nano Banana Pro, then my image will be, vastly improved in terms of output, because I am using the expensive model. So this way you can try multiple models, and then you can take a decision like for your multi-agentic pipeline, you need to use this type of model. For this purpose, this AI, Google AI Studio is very good. And this way you can use all Google models. You can test all Google models which are available right now using this platform. And this is a free from the Geo for 1.5 year. And this is along with the Gemini usage which you are doing. So you are only, if you are using only this, you also try to use Google AI Studio also, because it is free and it has like lot of things which you can try, and you can play with the model parameters, etc. And you can immediately see the output difference in terms of what it give. And main thing of Google AI Studio is what I have given here. If I need to implement it programmatically, I can only see like get a code. Okay, so this is a code which is ready-made code it has given, and I can, copy this code and I can run it into the my coding editor, and I will get the same output. So it has the best part of this Google AI Studio. So if you give something here in Gemini, you will not get a code or whatever the code version of it. But in Google AI Studio, if you give some prompt here, you can directly get a code of what that prompt is in using this code button. So if you see this, it has given exactly which model it has used. Okay, so if we see, this is the API key which always of course we need to put. Then model is Gemini 3 Pro image preview. So we just need to get this API key from now Google platform, and then directly I can run this code and I will get the whatever the output which it has given here, and the same is true for say other models also. If I select here say text model, so here Gemini 2.5 Pro. So Gemini 3.5 Flash, say okay, and then I say this is the playground, and I say okay, Gemini 3.5 Flash, okay, write essay on Pune University in 200 words. Run. So this prompt I have given, and now what I want is I need to write a program for this in my multi-agentic pipeline. Then I will just click on this get code, and it will give me the exact code what it has written to get this prompt. So it has used Gemini 3.5 Flash, and then the input text here, and then it will produce the output, and output is always produced like this. So this is the print, and what this print text is, this output which it has printed. So I can programmatically also get the say picture of regarding because I have tested the model here, but now I need to write the program or write the code in my agentic pipeline. Then in that case, this get code button is very useful from the Google AI Studio, where I will get actual code of what Google AI Studio has done for writing this essay. So this is very useful thing which you can use with the Google AI Studio, and this will reduce a lot of your work regarding the programming and anything, because main thing is testing is one thing, but writing an accurate code as per the Google specification is another thing, which will be easy if you use this get code button. So I hope like all things are clear now regarding the prompting techniques and the whatever the prompting techniques we have seen till now. So we have seen the few shot learning, we have seen the reflection. Reflection means chain of thought, and chain of thought will ask model to think itself, and then reflect and then correct the output depending on the its chain of thought or the reflection results. So this thing which we need to understand is like here old models versus the new models. So the new 2026 models are like a senior engineers, which are like self-sufficient and which can take their own decisions, and which can say act on their own. So what is the main difference between the agent and the normal chatbot program? If we think from that angle, is like chatbot program will only answer user queries. So if user say there is one chatbot program for an say Reliance or the Amazon shopping, it will only say give user regarding whatever the information in its database, and whatever so user wants to return an item, then chatbot will only direct him to the returning site, and it will not process the return itself. But if that is an AI agent, then AI agent's main principle is react means reason and act and use the tools. So AI agent has an reasoning which is enabled, then it will reason on user input, then it will take appropriate action, that means act. So react is a reason plus act. And in AI agent, there is one additional thing which always be there is a tool use. So in terms a user wants to return something, then it will call a tool which will actually get this means actually return actually trigger the workflow of returning a goods to an website. So it is agent always comes with the reason act and tool use. So tool use is an thing or the API calling which are external to the agent. So in case admission agent has an say background check of an a student also. So AI agent will always reason, act, and then tool use means always trigger a background check of a student, and then it will produce the background check results, and then it will take a right decision, and it will direct student to the particular admission site. So this is like an agent has done reasoning also, then agent has used proper tools, and then agent has done its work on its own. So AI agent will not always wait for an human to take a decision, but it can take its own decision by doing a reasoning. That is the main difference between a chatbot or a general AI script or AI agent. So AI agent will not stop for a human to take a decision. It will always take decisions on its own, and with that it will always call an external APIs using a tool use case. So this is the main difference we need to understand between AI agent and a generalized Gen AI script. So this new models 2026 models will always be tuned for an agentic use. That means they can always act on their own, and they can run indefinitely in a continuous loop. So it is like they will not wait for an human in the loop to take an action, but they will always take their own decisions. And that's why in 2026 everybody is talking about the agentic programs. So agentic programs are like programs which can replace a human worker, and they replace human worker because they can take their own decisions on their own, and they can act on that decisions to make it proper workflow. So this is the main point which we need to understand for the 2026 reasoning model. And 2026 reasoning model are different from this 2023 model in terms, because these models can work in a continuous loop without breaking a workflow, and that's why they are useful for all type of agentic tasks. So, and here we have talked this already, because when one agent needs to pass its output to the next agent, then it needs to always pass into the predefined way, and that predefined way we need to decide, or we need to make it fix in terms of the prompting or the using this pydantic and the response API. So the pydantic is a framework given by the Python for strict type checking, and then response API means the whatever the response we need to get from a AI agent, that needs to be in a fixed way that we need to define already in our prompting, so that that AI agent will always give a response in that fixed format, indefinite, like in a fixed format at every time, so that the next agent will not get confused by looking new response at every time. So if the we like say from the API point of view, if one API always returns response in this fixed format, and then the next API which needs to consume that response will always get a fixed input, then it is very easy to do programming also, and the response consumption also. So this way, the same principle applies to the agentic pipeline. Like AI agent needs to always decide their input fix and output fix, because if that is not fixed, then always it will be a confusing pipeline, and the next agent will always needs to be do the game of prediction, like okay, what type of input I will receive now. So this prediction is always force them to the hallucination, and if we need to control the hallucination, then we need to work on the fixed input and fixed output formats. And this always also useful in terms of the rack pipeline, because rack pipeline is like, say why we use rag is to grounding our answer. So if a Keystone College of Engineering needs to implement a chatbot which will exactly give students the answers based on the college policies. So college has some policies regarding the admission, college has some policies regarding the fees paying, college has some policies regarding, say, exam, say exam form filling. So all these answers which we so any question student can ask to the chatbot, and chatbot needs to give answer without doing any hallucination. So how that can be possible is using a rag. So what is a rag is like, when LLM will give answer to the user, that answer always needs to be from the documentation or internal documentation of an enterprise. So RAG will help an LLM to give exact answer to the user depending on the internal documentation. So RAG is useful when the internal documentation needs to get referred, because LLM don't know your internal policies, because if we use GPT 5.4 or any other LLM API for this chatbot, that chatbot has all world's knowledge, but it doesn't know Keystone's internal policies. That Keystone's internal policies, we will make it available using a RAG pipeline. So what RAG pipeline is like, we will first feed all documentation in terms of the vector databases. Means we will store all documentation to the vector database, and when the question will come regarding, okay, what is the leave policy for a student, then that leave policy for a student, that question will convert into the vector, and that vector matching will take place. And what is the most nearest vector for this question uh, 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 will get extracted from the vector database as an answer chunk. And that answer chunk means, now what is the leave policy for a Keystone College of Engineering, that will be converted into some mathematical equation, and then mathematical equation will get mapping to the available knowledge into the vector database, and it will extract exactly what the leave policy stored from the documentation to the vector database, and then that all leave policy related chunks will pass to the LLM before giving answer to the student. So that means now LLM has a knowledge which is available from the Keystone internal documentation. So LLM will now process this question using the knowledge, and then will answer the student appropriately. And if LLM don't find, or the vector database don't have the knowledge to the that leave policy, then we need to set the prompt stricter way, that if there is a no knowledge, then you need to like LLM needs to say, I don't know, it is based on the provided documents and I cannot give the answer. So here what we are doing is we are controlling LLM hallucination. So we are instructing LLM strictly that if there is a no internal knowledge regarding for that question, then directly say user, I don't know. Don't give answer depending on your like your hallucinations or your internal knowledge. So LLM, like say GPT 5.4 has its internal knowledge, but our Keystone College of Engineering documentation, which we provide to the RAG pipeline, don't have this policy for the leave information. Then LLM will not find any leave information thing from the RAG pipeline. But in that case, LLM will hallucinate and give any answer to the student, and that is not correct. So for that, we need to implement a guardrail such that if you don't get any answer from a RAG pipeline, directly say no to the user, and that needs to be implemented strictly, so that LLM will say in that case, no, I don't have any knowledge of this from the internal sources, so I cannot answer your question. So this is very important for the RAG pipeline to implement using a prompt system. So this we can set in a system prompt. So if we don't set this in a system prompt, then if LLM don't get any answer, it will hallucinate and it will give any response to the student, and then student will also get confused, and it will he will act depending on the false information provided by LLM. So this is very serious if LLM has done some hallucination in terms of the exam. So if LLM don't know exact timetable of the exam, and it has created some hallucinated timetable and it has distributed to the student, then it will be like very dangerous situation, and it cannot be controlled externally. So that means you need to, when you are implementing a RAG pipeline, this is the first thing you need to implement in an LLM prompting, is that if you don't get anything from an internal sources, directly say no to user, don't hallucinate. So this is very important for a RAG pipeline, because many real-time things are depending on this, and if LLM hallucinate, then it will be, a big problem for a user also, and that enterprise also. So this is a very important point when you implement a RAG pipeline, is using a guardrails to your prompting. So you need to create a guardrails using your prompting. And main thing is like, say my chatbot is for the Keystone College of Engineering, but students are asking what is the, how is the, Iran and US war is going. So that question LLM don't needs to answer, because tokens are burning from the Keystone account, and you are answering, you are asking the world questions to the LLM. So this is not a chat GPT, this is an Keystone's chatbot. So that way you also needs to implement these guardrails using a prompting technique, that okay, if there is some question from an user which is not regarding the Keystone, directly say politely to user, okay, you can only ask me the questions depending on a Keystone College of Engineering, and other questions I cannot answer. So this guardrail also you need to implement, as you are creating a chatbot for an Keystone, and the students are asking other general questions, and the tokens are burning from a Keystone account. So that is very bad. So that way, when you are creating any agentic application, or when you are creating any chatbot related application, these guardrails are very important, and these guardrails can be only be implemented using a prompting, and that prompting can be a system prompt. So this way you are restricting LLM to only answer the questions regarding the Keystone, or only answer questions which have the documentation proof. And the best way is like, also give the documentation reference when answer ends, that is the citation. So you always ask LLM to give me the citation of the answer, from which document you got this say answer. So this way, for implementing RAG pipeline, these two things are very important to say to provide a guardrails in terms of what is possible and what is not possible, and to provide a guardrails regarding only restrict user to ask regarding the current subject and or the current enterprise. So this you need to be understand when you implement the system prompt for the RAG chatbots or the RAG application. And context engineering is like, you need to provide a proper context to an LLM regarding your work, because LLM don't know what you are asking if you are not giving the proper information regarding exactly what you are asking. So if you need to say artificial intelligence is a subject for a third year computer engineering as well as the second year computer engineering. So both have an artificial intelligence subject. But if you don't give the context to LLM, like you are asking regarding third year artificial intelligence subject, then that LLM can give you the response for the from the second year artificial intelligence also. So it's your responsibility to provide a correct context, because the best tool for LLM is like garbage in, garbage out. So when if an LLM is giving an garbage output to a user, then that means user has provided a garbage prompt already to an LLM. That means LLM is only mimicking the user behavior. So it is the best thing you need to understand is like, if LLM is not giving you the right answer, then that means you are at the fault, not an LLM, because you are not providing enough information to an LLM to give you the proper answer. So that way you need to provide a proper information, you will get a proper output. So this is the best rule you need to remember for the LLM world, like garbage in, garbage out. So if you throw garbage to LLM, LLM will throw garbage with double speed to you in return. And this is very important point, that you can't improve what you don't measure. Means if you don't know regarding what output you are expecting from the LLM. So if I have given something, like if I have given one program to an LLM, say, okay, so here I have given one program to an LLM regarding the sorting output. But if I don't know what is the sorting, or I don't know what is the right output for this question, write a code for sorting, or if I don't know what is the right output for this question, then LLM, if LLM hallucinates here, then there is no way I will get to know this is the bad output. So that means this is very important point to consider, like if you don't know what you have given to LLM, means if you don't know the work which you have given to LLM, and if you don't have any idea regarding what output is a right output, then it will be always you are on mercy of LLM. And please note one thing, the LLM is the biggest con artist in the world, in terms like if it has given some lie to you, it will create whole world around that lie to prove that LLM is right, because LLM will never say no, because when we train LLM, say for a child, when we tell him that this is a right or this is a wrong, we don't tell him that if this is a wrong, his marks will be cut down. But when in an LLM right now, if you see the training of an LLM, the training of LLM happens in such a way that it will be always taught to LLM that if the answer is right, he will get some brownie points, and if the answer is wrong or answer is no, he will his brownie points will get reduced. So if this type of training we are giving to LLM, then all the LLMs will never say no to you, because they internally thinks that if they don't give you the answer, their brownie points will get minus, because the training right now we give training LLM in such a way. When we train LLM or a train model, we train our algorithms, train model in that way, and that's why LLM will never say no to any question which you ask. They will always give you some answer, and if that answer is wrong, they will create a whole world to prove to you that that answer is correct answer. And if you don't know in that way, in that case, if you don't know what is the correct answer, then you will get fooled easily by LLM. And that thing is the most important thing which you need to know, that if you are giving some task to LLM, first you need to know what is the right answer for that task. If you don't know what is the right answer for that task, and if LLM hallucinate, then only God will save you. So that is the main thing which everybody needs to understand, is like LLM can fool you easily, but you need to be in controlled you need to be in a like commanding or controlled position to check what answer is correct and what answer is wrong. That's why always give a work to LLM which you know how to do it, or which you know how to or what is the right way to answer it. Then it will be you can gauge the answer from LLM is a correct or wrong, and you can take a corrective actions. So this is very important thing and most important thing right now in today's LLM, because Google always give you no for no answer, but LLM will always give you some answer, and that answer can be wrong or that answer can be right. So you need to be you need to have knowledge of that thing. If that answer is wrong, you need to get you need to be in that position to this like think, okay, this answer is wrong and I need to give the prompt to LLM in such a way that it will give me the right answer. In case of the wrong answer, don't argue with LLM, because you cannot win, and it will always create a whole world to prove his answer is correct. So if you know that answer is wrong, break that loop there and create a new chat thread, and with the proper prompting to get the correct answer. That's your responsibility. That's not an LLM responsibility. So that is the main thing which you need to be aware of. Okay, so for today, this is the session. And please let me know if you have any questions for me to answer, or any feedback regarding the uh, uh, things which I have told you.
Yes, participants, you have any questions? Please ask. You can ask through chat box also. Yes, any questions? So there is one question. What is a tree of thoughts and graph of thought?
So basically, tree of thought and graph of thought is the same. Mainly, their variations are different. So tree of thought is means you are asking an LLM to show the reasoning tokens, and it depends on model to model how it will show the reasoning tokens. But mainly, it is an a way to ask an LLM regarding show me the your thinking, and then we will tune the output for more user friendliness, depending on what LLM and how LLM thinks about the question.
Yes, one more questions. Yes. Good evening, everyone. I am Professor Sonia Dhotre on behalf of Department of Computer Engineering, Keystone School of Engineering, propose vote of thanks. I express my heartfelt thanks to today's speaker, Mr. Rajesh Pandre sir, for the informative and very engaging session. Sir covered the various interesting topics: 2026 reasoning model, advanced prompt engineering. In that, we already learned LLM model yesterday, but in detail we learned today. And a few short learning, zero shot learning also we learned yesterday. So we will learn now in detail. Then the CTCO, that is a context, task, constraints, output, 80% framework, positive and negative sentiment categorization, chain of thought prompting, context engineering, RAG, which reduces the hallucination, and the most important is the model that is a nano banana model. I sincerely thank to our director, Professor Yashodhan Soman sir, Principal Dr. Sandeep Kadam sir, HOD Computer Department, Professor Sagar Raje Bhosle sir, management team, entire FDP organizing committee members, and all the participants for making the day 2 successful. Kindly submit your feedback through the provided feedback link. Please turn on your camera for the group photo. Okay, we will meet tomorrow on the same timing. Thank you and best wishes to all.